Okay, welcome class. Okay, so now the last of the basic functions we're going to talk about is the greatest integer function. This is the one that is probably the most complicated one. It is difficult for students to think about, to understand, but it's not impossible. Okay, if you spend some time looking at it and understanding the characteristics of it. Okay, so I'm going to do my best to explain what's going on here and how this function works. Okay, so this is the symbol for the greatest integer function. So it's like these square brackets, but it looks like it's like bold-faced square brackets with the x in here. So what does this function do? The greatest integer function basically says whatever value of x you put into the function, it's going to turn out or produce the largest integer that's less than that value. Okay, so again, let me repeat that. So the greatest integer function takes whatever x value you put in, okay, and it will produce or spit out the largest integer that's less than that value. Okay, so for example, if I put in 1, okay, the greatest integer to come out of that is that's less than that value is going to be 1, or less than or equal to. Okay, is going to be 1. Okay, so if I put in 2, what do I get? I'm going to get 2, right? Because the greatest integer that's less than or equal to 2 is 2, right? But what if I put in 1.5? What if I put in 1.5? Then what is it going to spit out? It's going to spit out the greatest integer that's less than 1.5. Well, that is going to be 1. What if I put in 1.9? Well, the largest integer that is less than or equal to 1.9 is 1. Well, what if I put in 1.99? Again, I'm going to get 1 out. What if I put in 1.9999999? Well, I'm still going to get 1. Okay? So no matter how close I get to the next integer, if there's a fractional addition to that, it's going to bring me back down to the next smaller integer. Okay? So what does that create? Well, it creates this stepwise function. So that's what we call these. We call these stepwise functions because they look like stair steps. Because notice at 0, it's 0, right? So we have these. So it's a circled in. It's a solid circle, right? It's a filled in circle. And then as you go across, as you're getting closer and closer and closer to 1, what's the value of the function? Well, it doesn't go up because remember, the greatest integer function says, hey, I'm going to give you the largest integer that's less than this number. Well, from here to 1, it's just going to give me 0, right? Because if I put in 0.5, the greatest integer less than 0.5 or less than or equal to 0.5 is 0. So, but as soon as I hit 1, it jumps up to 1 because now the greatest integer that's less than or equal to 1 is 1. But then as I go across from 1 to 2, it's going to stay at 1 until I get to 2, and then it's going to jump. So notice that at the jumps, I have a open circle. Okay. So what it does is it creates these stair steps where this side is a filled-in circle, this side is a open circle because I'm never going to reach that value because as soon as I reach that value, it's going to jump to the next integer. Okay, and this is how the greatest integer function works. Now, if I go in the negative direction too, you got to be careful. The negative direction is, again, it's going to keep going this way, but if I'm at -1 and I'm getting closer and closer to 0, so I'm getting bigger, so -1, -0.5, -0.4, -0.1, I'm going to, again, what does the function give me? It gives me the greatest integer that's less than that number. Well, what's less than -0.5? -1. Okay, and so on. So it continues going on this direction. Okay, so in this case here, if I was filling this in, Okay? So at 0, I'm going to be at 0. If I go to 0.5, I'm going to stay at 0 because that's the greatest integer that's less than or equal to 5. If I go to 1, well then that's going to jump up to 1. Now here, if I do negative 0.5, well what's the largest integer that's less than or equal to 0.5? Well that's going to be negative 1. So this is going to be negative 1. Well at negative 1, that's still going to be negative 1. Okay? Then at negative 1.2, well now it jumps up to negative 2. Okay? Or down to negative 2 if you will. And then here, it's going to stay at negative 2. And then here, it's going to be negative 2. So I get this stair step where it's constant on these intervals. Okay? So let's talk about the characteristics. So, domain. Well, if you look at the domain, there are no x values that are being missed. This here, even though this is an open circle, x is covered here. So if you put all of these stair steps together, you get the entire number line. So the domain is everything, the entire number line, negative infinity to positive infinity. Now the range, on the other hand, is not the whole number line. It's not because what happens? It's jumping. Where is it jumping at? It's jumping at the integer values of y. So there's nothing in between. So the only values of y that are coming out of this function are the integer values of y. So that means the range are all values of y such that y is an integer. Or if you wanted to use this notation too and just write out the negative 2, negative 1, 0, 1, 2 and put these ellipses here, the ellipses tell the reader that, hey, this is continuing in both directions the same way, okay? But again, this is the way I would do it, but again, if you just be careful when you do it this way, that you write what you mean to write, okay? So again, set builder notation is probably the easiest because you're saying all values of y such that y is an integer, and you're done. So the range are all integer values of y. Okay, now, the behavior of this graph. So in this case here, this is an increasing function, but remember, what's the behavior at this? I mean, it's obviously going left, up from left to right, but we would not call this an increasing function, okay? This is a constant function. Well, okay, I don't want to say it's a constant function either. It is increasing, but it's constant on the open intervals. Let's just put it that way. So this is constant on all of these open intervals. So what are these open intervals? The open intervals are from 0 to 1, right? Or 1 to 2. Okay? So what we get, oops, let me get out of the way. So this translates to here, on all open intervals, from, for example, negative 2 to negative 1, negative 1 to 0, 0 to 1, 1 to 2, and so on and so forth. So again, I put these ellipses here to say, hey, all the open intervals in between consecutive integers. Okay, so 1 to 2, 2 to 3, 3 to 4, and so on. Negative 1, negative 2 to negative 1, negative 3 to negative 2, and so on. Okay, so it's constant on all those open intervals. Now, continuity or continuous. Well, in this case, it's easier to talk about discontinuous. So in this case, this is discontinuous at all integer values in the domain because that's where the graph jumps. It's continuous everywhere else, but the easiest way to say this, as far as continuity, is to talk about where it's discontinuous. So we would say that, hey, this is discontinuous at all integer values of the domain. So at all integer values of x, that's where it's jumping. So that's where it's discontinuous. Okay, and that's the way to understand the greatest integer function. Okay, so again, we're going to do more examples, but these are the basic functions. So there are 7 basic functions you need to know. Okay, make sure you know them and you know their characteristics because it's going to be important later on. Okay, until next time, have a great day.